Purpose of this video is to look at some boundary condition problems and how to use integration to find the original function, given that we have a bit of extra information there. Alright, so we'll have a look at a few examples. Okay, so integration can be used to find the original function, okay, if we know the derivative and some fact about the original function. So we'll have a go at example 1. Hopefully you'll get the idea. So example 1, find f of x if f dash x equals x squared and f3 equals 6. There's a lot of detail going on there. What this is really saying is find the original function, okay, if the derivative is x squared and f of 3 equals 6 means when x equals 3, the y value or the function value that's pretty much what it's saying. Okay, so I'm trying to find the original function. I know the derivative is x squared. So to find the original function, I know that I need to integrate whatever the derivative was. Okay, with respect to x. I need to do the undo of it. I need to undo the differentiation. Okay, I'll do my thing, add 1 to the power, divide by that new power, plus c. Yeah, that's my function. Okay, but I'm not happy with this plus c because this is just saying to me that the original function was x cubed on 3 plus some number. Okay, but that's not good enough for me because I can't substitute in x values. I can't then find what's f of 10. Okay, it's not good enough for me to tell someone that the function value at 10 is 10 cubed on 3 plus some number. Okay, that's not good enough for me. I need to be able to substitute values in precisely. Okay, so what I'm going to do is use the fact that I know that f of 3 equals 6. Okay, so since I know that when I sub in x equals 3, I'm going to end up with 6, I can make this equation that 6 equals substituting 3 in where x was. Okay, I'll use a different color. Okay, I can then solve for c. Okay, so to get c by itself, 6 equals, so 3 cubed, 27 divided by 3, 9, plus c. I know my c value is going to be minus 3. Okay, so my original function f of x will be x cubed on 3 minus 3, because my c value is minus 3. Okay, this will go at the end. Okay, instead of the c, I've put my minus 3. Any questions? No, good, because this is the video. Okay, example 2, using slightly different notation, find the original function. Okay, so find y if the derivative is 1 on x plus 3 when we've got this condition. Okay, pretty similar problem. To find y, I'm going to need to integrate 1 over x plus 3 with respect to x. Okay, do the opposite of differentiation. Hopefully I remember the rule where if I have a function on the bottom and its derivative on the top, and I'm integrating it with respect to x, it'll be natural log of f of x plus c. Okay, do I have this scenario here? I've got a function on the bottom, x plus 3. The derivative of x plus 3 is 1, so it looks all good. So this will be natural log of x plus 3 plus c. Okay, again, I'm not happy with this plus c here. Okay, I want to use the information that I know. So I know when x equals 0, y equals 0. So I'll substitute those two values in to try and find this c value. So from here, 0 equals natural log of 0 plus 3. Yeah, that should be absolute value around it, plus c. So 0 equals natural log 0 plus 3 is 3. Absolute value of 3 is 3. Plus c. The c value will be negative natural log of 3. Okay, so my original function will be y equals natural log of x plus 3 minus natural log of 3. And then I'll be able to use this function to substitute in any x value to find the y value without there being c's anywhere. So these are two abstract problems where there's no words in there, no scenario. When I look at a life-related problem, which there'll be heaps to practice. Make sure I get it all on the page. Yep. Okay, so the weekly sales S of a company are increasing at some rate. Okay, according to this formula, ds dt equals 0.1t, where t is the time in months. And if initially there were 50,000 monthly sales, how many sales will be made after 2 years? Okay, so I'll highlight the things that are really interesting in this problem. So I know that ds dt equals 0.1t, and initially there were 50,000 monthly sales. Okay, highlight the thing I'm trying to find. How many sales will be made after 2 years? So I need to use the facts that are in yellow to try and solve the problem that's in green. All right, I'll have a go at this. So I'll write down this fact that ds dt equals 0.1t. I'm trying to find s. So I know I need to undo this differentiation. I need to integrate this side with respect to t. Okay, always to undo differentiation, need to integrate. Pretty much the integral of ds dt with respect to t is s. Okay, so you can imagine these sort of cancel. Okay, and we're just left with that original function s. Okay, that's sort of the undoing. Okay, to find s, do my integration as per usual. 0.1 comes along for the ride. Increase the power of t by 1 and divide this by the new power of t plus c. Okay, neaten it up a little bit. 0.05 t squared plus c. Okay, all good so far. So I've used this piece of information. Okay, there's another piece of information. If initially there were 50,000 monthly sales, so I know that when t equals 0, s equals 50,000. Okay, I'll substitute these values in to try and find c. So I know that 50,000, I'll communicate what I'm doing, sub into formula for s. Okay, so 50,000 equals 0.05 times 0 squared plus C. C value is 50,000. Looks good. And this is how it'll be in the majority of cases. This C value will typically be the initial value. Okay, for a lot of cases. Okay, so my sales equation or relationship is S equals 0.05 T squared plus 50,000. Okay, I've used that piece of information. I'll look back to the question, make sure I answer the question. How many sales will be made after 2 years? Great, I've got the equation. I haven't answered the question. Okay, so now I need to find S when T equals 2. So I'll substitute that in. S equals 0.05 times 2 squared plus 50,000. I'll go to my calculator for this. Okay, 50,002. Okay, and 20 cents. Okay, so it doesn't seem to be increasing very rapidly after 2 years. I made a mistake here, obviously. Okay, after 2 years, where's the mistake I made? It should be when T equals, and this is good because you'll be able to change it relatively easily, T equals 24. Okay, because T is time in months, but 2 years should be 24 months. So I should have a 24 in there. Okay, and I should be able to change that on my calculator as well. Okay, I did that so that you can see how easy it is to change these things during exams if you make a mistake. Sure, that'll do. Okay, $50,000 and $28.80. Okay, so the sales have grown $28.80 over 2 years. Okay, probably not the best example because I just made up the data, but you can get the idea. So for all these worded problems, always write some worded statement at the end. Okay, would make this many sales after 2 years. Okay, and then from there, you're good to have a go at some more of these abstract problems. So these are all the problems, these are the solutions. Okay, and more importantly, having a go at some of these worded problems, okay, that get pretty interesting. All of these sorts of problems will always just be m equals integral of this guy with respect to t. Okay, and all of the formulas are provided, so you should be able to have a good crack at these, and we'll have a look at some solutions for them if you have problems next week.